Okay, next example. A little bit more interesting. We've got a function of k squared minus 7k plus 12 over 2k squared minus 4k minus 6. And we're trying to determine what is the limit of the function as k is tending towards 3. All right, k is now just the variable we're using, but exactly the same concept, okay? Well, what you're going to find here is that if I just took 3 and I just substituted it into all the k's, you're going to land up with a value that is undefined. You're going to land up with a 0 in the denominator, okay? So we don't want that. We don't want a 0 in the denominator because that then tells me that the limit doesn't exist, okay? So how do I fix that problem of having a 0 in the denominator? Well, basically this is what you need to do. You need to factorize numerator and denominator as much as you possibly can. Now, while we're in the process of factorizing, we need to actually make sure our notation is correct, okay? While you are still just simplifying and kind of working out your f of x function, you're not actually working out the limit yet. So in order to indicate that we're still needing to work out where the limit is, we still need to write the limit as k is tending towards 3, all right? And we need to just work with this over here. So I'm factorizing this trinomial, so I've got a k and a k, factors of 12, 3 times 4, both of which would be negative. That's going to give you your 7, all right? Then we've got over, and I've got another trinomial, which we are going to factor. And first things first, in fact, actually, do you notice that before we deal with it as a trinomial, we can take out 2 as a common factor. Please always make sure you check for common factors. Okay, so we've taken out a common factor, but I still need to factorize that trinomial at the bottom. So therefore, notation, we're writing limit as k is tending towards 3. We keep that there until we substitute into the f of x equation. And we've got k minus 3, and I've got k minus 4. All right, it's over. And now we're going to factorize this trinomial, which is a nice easy one. We've got k and we've got k. 3 and 1 are the factors of 3. That needs to be negative. That needs to be positive. Okay, so now do you notice? I've got a k minus 3 at the top and I've got a k minus 3 at the bottom, and they are going to cancel beautifully, all right? So now the fact that they've canceled actually solves your problem of having an undefined fraction, because look here. Now what I'm going to do is I'm going to say equals, and I'm not going to write k tending towards 3 because I'm actually substituting 3 into the k's now, all right? So we've got 3 minus 4 over our 2, and instead of k, we've got 3 plus 1, okay? And what's that getting us? I've got a negative 1 down here. That's 4 times 2, which is 8. So there we go. It does exist. The limit exists where k is tending towards 3. Y, your limit would be tending towards negative 1/8. However, at the point where x equals 3, your limit would not exist, okay? The value of the function, in fact, would not exist. But the limit tends towards negative 1/8 from the left and from the right. And there we go. That's our limit. All right. Okay, I've got one more example I'd like to do with you before we move on from this. So please give it a try.